All right, guys. Well, welcome to our 7th webinar. And this one, we're going to go over some decoder installation general guidelines. We're going to show you some specific examples and also kind of some tips and principles to keep in mind when you're doing your installations. Now, first off, I just want to introduce myself. My name is George Bogatiuk. My primary function here is a product specialist and on the sales team. And so I primarily talk to the hobby shops, the retailers, and then I also go out and spend a lot of time talking to you guys at shows and clinics and other meets and things like that. So now the first thing we want to do is we want to talk about the tools and supplies that you want to have on hand. First off, of course, you want to have a soldering iron. Just really to get fundamental, we always recommend you solder your wire connections and your terminals onto the decoder boards, things like that. It gives you a much better connection. And a very reliable one. And once you practice soldering and get used to it, it's actually a very easy task. It's not quite as difficult. And of course, you want to make sure you have the right tools. So first off, we'll start with a low wattage soldering iron. The one you can see there pictured is one that I had bought years ago from Radio Shack. And I do realize the Radio Shacks aren't around anymore, or at least not on every street corner like they used to be. But they do still have an online presence. You can also find similar ones that you can buy online from Weller and other brands. But ideally, this is a good soldering station because you can adjust the temperature. The plug is grounded. We have had a couple instances where customers would have continued failures, come to find out that their soldering irons were cheap $10 soldering irons they bought years ago, and it was actually grounding or sending voltage through the tip into the decoder and causing damage. When they found that out, they changed soldering irons, problem went away. So make sure you get a good one. You also want to have a fine tip so that way you can really get into your work and you can get those tight fit applications. You don't have to worry about possibly touching wires or anything like that. You want to use a rosin core solder. I always recommend the smallest diameter you can find. We here use a lot of lead-free stuff, so our equipment's a little bit different. But this is the kind of some of the stuff that you're mostly going to be able to find at home. But the reason I recommend a small diameter solder is because you can always add solder to your joint. It's a lot harder to take a little bit away. So if you're using these big giant diameter solders, you probably want to go look and get, spend the $10 or $15, whatever, and get you a nice roll of very fine diameter solder. The next one I cannot stress enough. You want to make sure you have flux for work with electronic projects. There's a lot of times we'll see failures come in because they're using pipe flux or whatever they find at the Home Depot. And the biggest issue there is that the different fluxes have different purposes. And so the higher acidic content tends to attack the electronic components on our circuit boards. And so what you want to do is you want to make sure that you get a flux that's designed for work with electronics. Now, what flux is this is a paste or a liquid type material that you can brush onto your joint or put onto your joint. And what it'll do is it helps clean the material, the metal that you're soldering, and also will help draw the solder off your iron and into the joint. Really quickly, we're going to be doing, our next webinar is going to be successful soldering, so we'll get into the tips and details of how to do this. We'll actually show you examples live right here on there, but we also will have some tips on our YouTube channel as well, so be sure to check those out. Now, moving in along the list, you want to have a good set of wire strippers. You want to make sure that you have an adjustable diameter wire stripper, so that way you're not cutting the wire and you're just pulling off the insulation on your wire. You want a good multimeter, something you can use to go test for continuity, test for resistance, things like that. And of course, you're going to have a mini screwdriver set because you are going to be disassembling the model, so you want to make sure that you've got the tools that you need. It's always good to have a hobby knife around. This is something I always recommend to use silicone or RTV sealant. What this will do is you can use the silicone to secure your speaker in place, and we'll talk about that a little bit more as we get further into the clinic here. Or you can even use it to tack wires up into the corner of your shell so that they're up and away and out of the mechanism. The thing I like about using silicone is the fact that it dries fairly quick and solidifies, but here's the best part is it will adhere to the plastic so it doesn't attack it, but if you need to remove it for whatever reason, it's easily pliable so you can pull it right out without damaging the shell. If you were to use something like cyanoacrylate or super glue to help hold your wires in place, if you remove that, you have to get in there with your knife and start chiseling it away and potentially can damage, especially if you're trying to hold the shell with fine details. So you want to make sure that you're using silicone so that way you can just pull it out if you need. Diagonal cutters, wire cutters, something like that. Dremel tool or a hacksaw, we may need to remove some weight. We'll talk about that. Ideally, a milling machine, but not everybody has access to one of those. So you want to make sure you've got some tools to be able to remove weight or modify the body shell if needed. And then a heat gun or heat source for heat shrink tubing, which then, of course, leads us to our other little small things that we might need. Heat shrink tubing, micro connectors, or our DBX 9000. These are different types of connectors that allow you to disconnect the body shell, or in the case of the DBX, it's a locomotive to tender wiring kit that you can just simply unplug, separate the locomotive and tender for storage in its original box or servicing, things like that. Speaker gaskets, we have a bunch of laser cut speaker gaskets that help adhere speakers to either the mounting inside the body or the mount that you've provided. So they're laser cut, designed to fit our speakers. Sheet styrene or a speaker baffle. As we talked about in one of our classes, DCC and sound theory, you do need a baffle for every speaker because, again, as the speaker cone moves air pressure, you want to baffle that from the front and the back of the speaker. So we're going to be building baffles in some cases, or we can use the commercially available baffles that we have in our product line. Double-sided tape, you can use that to mount the decoder or other things up and away inside the shell, things like that. And then you want resistors or any LEDs or light bulbs or anything that you're going to be installing with the model. You want to make sure you have all that on hand when you're ready to go. So when we look at our model, we got several basic steps. These are common things that you're going to see with any installation that you're going to do. First of all, you're going to select the locomotive, and I'm highlighting testing the stall current. We're going to have a brief conversation about that again and why it's important. You want to plan out the installation. You want to make sure that you're not kind of doing it on the fly. You want to make the installation look clean. Also helps you go back and do better troubleshooting if you do find something wrong. We'll make any modifications to the body shell or the frame, fit the speaker and secure it in place, install and wire the decoder, and then we're going to test the installation before we're finished up and ready to go. So first up, what we're going to do is we're going to match the decoder to the locomotive. So when you select a decoder, you want to make sure that the model you're installing into has all of the features that are going to work with the decoder. We're going to talk about how to do that. So first off, the first thing you want to do is pick a smooth running model or tune up the mechanism. The old adage with DCC is that you can make a good model run great with DCC, but you cannot make a poor model run well with DCC. And there's so many different instances and things like that that you can go into. If you have sticky mechanisms or binding gears, you want to clean that stuff up first before you really get into it. Speaking of gears, avoid the ones with noisy gears, because then that gearing, that grinding, that sound's going to compete with your sound coming out of the speaker. So you really want to make sure that you clean that up and have a smooth running mechanism and a quiet mechanism before you go install. Now, this is something I really highlight here. Don't attempt to test or tax your skills on the first try. For those of you guys that are learning for the first time, don't grab that brass model of that 484 that is, several $1,000s worth and go to do it and start hacking it up and end up finding out that you ruined the model. Start with something good and easy to start with first, whether it be a plug and play or a simple rewire, something like that. That way you get familiar with what you're doing first and then work your way up to that as you learn different tasks. The other thing I want to highlight here is the term DCC ready, and this is one that apparently trips people up a lot all over. The term DCC ready simply means that the motor is isolated from the frame. Usually, in a lot of cases, let me show you some things here. We've got a whole bunch of different circuit boards here that I've taken out of models over the years. These are different circuit boards that basically all do the same type of thing. You recognize this picture, this was one that was in the picture there. This is the one out of Athearn. They have their 9-pin DCC quick plug. And so the advantage here is we can simply unplug the dummy jumper, set it aside, and then we can plug in our TSU 2200 right there. Or we can replace this whole PCB with a TSU PNP. A lot of these circuit boards you're going to see are very similar. This is one out of a Kato model that, again, a PNP board would simply replace it, or you can plug into the 8-pin plug. In this case, these jumpers, which may be hard to see on the camera, so I'm going to apologize in advance, but they're small little metal. Let's see if we can show that off really well there. It's just a small little metal jumper that's just bridging the gap between the 8-pin plug. And so we unplug that and can plug in, and then this way we retain our LEDs. But we're going to talk about those here in a little bit. But other circuit boards like this one here is actually doing the same thing essentially as this one. I'm not sure why, but this one looks like a 1970s science project out of something, but this is one that we removed. We replaced this with a TSU PNP. But if you look really closely right there, there's still the 8-pin plug. So for whatever reason, they felt they needed all these components on there. But essentially all of these are doing the same thing, is they're taking the motor and routing the power from the track through the circuit board to the motor. So your motor is isolated from your track pickups. Now in another instance here, this one here, a lot of you guys will recognize as an Athearn standard blue box chassis. I kind of have it sort of in pieces right now for demonstration purposes. But what happens is the track pickup on here, on the wheels, on one side of the rail, are going up through what I'll call these question mark shaped brackets right here on top. And so this is transferring track power from the wheel to that. And what Athearn has done on their later versions is they've actually included a wire to go to this circuit board that sits right here on top. Now the other side of it on the old blue box is actually transferring power through the top of this truck. And you can see this metal right there, you can kind of see it. That metal piece right there is actually transferring power to the frame. And so when that touches, it's transferring power to the frame, so your frame is hot. Now in the old blue box, the way this was handled was they had the motor actually had some teeth on the bottom of that motor that touched the frame. That's how power is transferred through the body shell. So what they've done with DCC Ready now is you take that and you remove the tabs, and then they have a wire attached that runs up to the decoder, or in this case, the circuit board. So DCC Ready simply means that the motor is isolated, and you can then go in and make your connections the way you need. So the DCC Ready doesn't mean that it has a plug. The other thing DCC Ready means is that it does not have a decoder. If it says DCC equipped, then we know it has a decoder built into it. But if it's DCC Ready, it does not have a decoder. So you will need to install a decoder of some form. When we're doing a decoder installation, we want to test our stall current. And this is something that apparently there's a whole lot of myths out there and misunderstandings of why we're measuring the stall current. The stall current is not measured because we think you're going to lock up the drivers and we want to make sure. And so a lot of people say, well, I test for slipping current. Well, that's because you don't fully understand what's happening fundamentally with the decoder. So years ago when we were working with power packs, it was very simple. We adjusted the knob on the power pack, more voltage went onto the tracks, motor turns faster, model goes faster. Very simple. Decoders don't work that way. Decoders do not adjust the power going to the motor. What they actually do is they send momentary pulses of full track voltage, but for short periods of time. As you increase the throttle, the duration of the on period versus the off period becomes longer. This is what's known as pulse width modulation. We are modulating or changing the width or duration of the pulse to determine how fast that motor's turning. The reason this is important, guys, is every time you go from 0 to speed step 1, you're creating a stall condition. Again, it has nothing to do with we think you're going upgrade and you're going to stall your motor out. That's going to happen on occasion, especially if you've got a steam locomotive with rubber traction tires and a really heavy train that's underpowered. Yes, it can happen, but the reality is this is why you measure stall current. Because if you've got a motor that stalls at say 1.5 amps and you have the 1 amp decoder attached to it, every time you go from 0 to speed step 1, that thing's drawing an amp and a half. You're running the risk of damaging those motor components inside the decoder. Therefore, you send it back. If you don't measure your stall current, you can't expect to know. Don't always go with the 1 amp. The other thing is the decoder will supply up to its rated value. So a 1 amp